All right, which of the following has the smallest probability? All right. Okay, so they all are based on some value of 2. All right. Probability that t is greater than 2. Okay, so t distribution, degrees of freedom, 5. Okay, so t greater than 2. So that was choice A. Choice B is the same thing except the degrees of freedom are 2, but it's still a boundary value of 2. C is Z, so this is a normal distribution. Boundary value 2 or greater. D, same boundary value, but notice it says less than 2. All right, T with degrees of freedom 5. So here's the boundary value, positive 2, but less than is the left tail. And E, okay, boundary value 2, but it's being less than, and this is a normal distribution. Okay, so just based on the pictures alone, I'm going to eliminate A, B, and C. Oh, no, sorry. Which of the following has the smallest probability? My bad. So we're going to eliminate D and E. Those are going to have the largest probabilities. And so now let's go ahead and do A, B, and C. Now, before I calculate it, I'm already going to be leaning towards C because I know that the T distributions, although similar to the normal distributions, have smaller peaks and thicker tails, right? So this tail is going to be thicker, which means I think it's going to have more area in it, right? That's going to be a thick tail, so have more area. This is a normal distribution. It should have a thinner tail or less area. But to confirm that, I'm just going to use my calculator. I'll use TCDF and normal CDF to find some areas. Okay, let's do TCDF first. So lower bound 2, upper bound 999, degrees of freedom 5. And sorry, I'm doing this off screen so you can't see. All right, this has area 0.0510. I'm rounding. Okay, next we'll do TCDF, lower bound 2, upper bound 999, degrees of freedom 2. Okay, this has area 0.0918. Okay, and then finally, normal CDF, lower bound 2, upper bound 999, mean 0, SD1. And this has area 0.0228. Okay, so of the 3 that we haven't eliminated yet, C has the smallest area. Okay, again, so T distributions and normal distributions have a lot of similarities, right? They're symmetric, they're single-peaked, they're mound-shaped, but the differences are that the T distribution, and here let's draw a picture, right? So let's start with a normal distribution. So that's standard normal distribution. T distributions are going to have a shorter peak and thicker tails. So those are the T distributions.